Thank you very much, Mark. It is also my great pleasure to be here with you this afternoon. And so thanks again to the organizers for having invited me to these plenary lectures in this nice city of Porto. So, as Mark says, I would like to speak about operations research and voting theory. There will be 4 parts. The first one will be devoted to a kind of electoral tale. It will be the opportunity to recall some voting procedures and a little bit of the history of electoral procedures. Then we'll go to Arrow's theorem. It will be a short part, very short part, maybe only 2 slides or something like this. But Arrow's theorem is very important in this field. Then we'll go to some more technical parts where operations research appear with some voting procedures based on the concept of the Condorcet winner of an election, if he or she exists. And then we'll go to the end with some, maybe funny, kind of paradoxes. So, which kind of paradox we would like to cope with? Paradoxes like the answers of these questions. In an election, is it possible that a candidate who is preferred to any other candidate by a majority of voters, what we call a Condorcet winner, is not elected? And in fact, the answer is yes, it is possible. And in fact, it is usually the case. Is it possible that a winner becomes a loser because he or she obtains more votes? The answer is also yes, as we'll see thanks to some examples. If I want my favorite candidate be elected, may it be better to vote for the candidate that I like the least, what we call manipulation, in order to elect the candidate that I prefer? May a candidate become a winner while he or she regresses in the voters' preferences? Another kind of question, can it be better not to vote, what we call abstention, or also no-show, rather than voting for the candidate we like the most? Last kind of question, if a candidate X is preferred to any other candidate Y by every voter, unanimity, is it possible in a way that Y is elected and not